Okay, hello everyone. So today I wanted to talk to you guys about how we can use augmented reality to improve trust, safety, and comfort of driving, within quotation marks, if implemented correctly. Otherwise, it can be the exact opposite of all these three things. So that's something we will talk about as well. And I wanted to kick things off with a small experiment. And for this experiment, I would like you to imagine that you've developed the perfect autonomous driving car that can perceive the environment 100% correctly, and you get into a situation of an unavoidable crash. So essentially, I'm going to give you two variations of the trolley problem, as you might have known, right? So if you were completely unavoidable, you had an unavoidable crash, and the only choice you could make was to save a child or a grandmother, who would you rather save? So who wants to save the child? Okay, so that's a good number of people. Who wants to save the grandmother? One. Two. Okay, so yeah, so the grandmother's probably not very happy, and this is consistent with the survey results as well, which MIT did. They found that Western countries preferred to save the young because they have their whole lives ahead of them. Eastern countries prefer to save the old because there was a lot of wisdom in there and the child had nothing, apparently. So what if we spice things up a little bit? What if there are two grandmas, or what if there are three grandmas, right? Who would you save now? Who wants to save the three grandmothers on the right? Okay, grandma's really not having a nice time. She just so people still want to save the baby. Interesting. So what the survey results found was that Western countries preferred to save more people, and Eastern countries did not want to interfere with fate. So there's a lot of geographical differences in what the right thing is. And we can keep going on, and you see that there is no general consensus on what should be the right decision, especially on these ethical dilemmas. And there will continue to be no right decision for a while. So the whole point here that I wanted to make with this experiment was that even if autonomous driving perception is perfect, which it's not, it's going to take a while until we solve all corner cases and so on, there is still difficulties. I mean, the world is not all 90-degree angles and people behaving perfectly well. It's always going to be tricky, always going to have edge cases and so on. So even if autonomous vehicle perception gets perfect, people still can't have full trust that it will do the right thing, because the right thing will continue to be different for different people. And in some sense, people lack trust in ADAS and autonomous driving because they sometimes feel like they do not know what the vehicle is seeing, and they do not know what the vehicle is doing. And that's why you have articles like this popping up every now and then, which says things like, there are some people, especially the older population, have trust issues with ADAS. They turn it off because it's annoying, or they don't know what it's going to do. Some are a little over-dramatic. I wouldn't say 9 out of 10, but apparently that survey said that. And as somebody who worked with ADAS and autonomous driving for 10 years, things like this really hurt. And so in our opinion, there are a number of solutions here, but one of the clear solutions is communicating what the vehicle is seeing and doing so that we can gain trust over time with the driver. This aspect of communication then leads to the challenge on the other end of the spectrum, because if you look at infotainment screens today, they're getting bigger, flashier, stronger, and you have so many talks about how we can make them less distracting by focusing on just on the passenger and privacy and so on. There are a number of solutions there, but essentially, drivers have a challenge in terms of cognitive load, especially as vehicles become more and more intelligent. You would want to communicate more and more to them. That causes a bandwidth issue. So how many times have you missed an exit and then had to drive an extra 20 minutes and you were very unhappy with the confused navigation system? How many times have you reached a destination and then looked for where is the entrance to this damn building or where is the closest parking spot? That's what I need right now. So essentially, the problem that most of us are trying to solve in different ways is how can we get the right information show up at the right time and in the right place in the driver's field of view or wherever it might be. So there are many solutions to this. Our approach to this is using augmented reality on different in-vehicle displays. You might have seen some of our products in the market already. For example, we helped BMW deliver an amazing augmented reality experience into the market. This is for the center screen that helps with navigation so that you don't miss turns. That might show you the closest parking spot and have like a nice destination arrival experience and so on. There are some other customers as well, which would release pretty soon. We're happy to show you after that point. So essentially what we do at Basemark is we try to enhance the different in-vehicle displays with interesting augmented reality features. We provide an AR engine that runs on the infotainment SoC that is capable of running AR content on different displays. So our stuff is the positioning of the content, and you can render it with any HMI framework that you would want to choose. So for example, if it's an instrument cluster, we could show, for example, things like lane departure warning, collision warning, night vision assist, and effectively improve the communication between the vehicle and the driver. We are working together with a number of HUD partners, holographic HUDs and laser-based HUDs. So there's a wide variety of HUD partners that we work with. And they are a combination of interesting navigation experiences, interesting AR-enhanced ADAS experiences, and some new experiences that is only possible with this type of augmented reality. So there is the navigation side, and then there is also the AR-enhanced driver assistance features that we do. And in terms of what we exactly offer, we offer a software development kit and some low-code tools that try to address the 4 biggest challenges in creating good augmented reality features for cars. And the first one is the challenge of latency. So anybody who's worked with AR immediately knows that that's a big problem. You see all these advertisements about having the whole windshield filled with interesting AR content and so on, which is something that probably looks amazing. But from a latency point of view, if you want to cover the entire field of view of the driver, you would need to achieve really tight latencies so that you don't face motion sickness. So the general idea is that the closer you visualize things to the sides of our vision, the more perceptible you are to latency. And these are typical challenges when you start working with AR, and we kind of provide a wide variety of latency compensation mechanisms that help avoid motion sickness, and we built it into the AR engine. Then there is the challenges in tracking and stabilization. So if you've ever tried to use any of the smartphone AR SDKs, they were kind of built for the metaverse or the AR on your smartphone in mind. They weren't built with automotive use cases in mind, which is very different from the environment in which you use that. So we built in a lot of automotive-grade stabilization mechanisms that make sure that the content sticks to the ground, it sticks to the target regardless of how you're driving as much as possible. And then there is the challenge that most of the AR content that you have today, it's already difficult to just solve the latency and stabilization problems. It sometimes has the challenge that because it lacks a sense of depth and semantics, it often feels like the augmented reality assets is a part of the display and not part of the real world, which it's trying to augment. So we kind of have certain built-in occlusion mechanisms that, for example, might draw this navigation line as if it goes underneath the car in front to add an extra layer of realism. But we also believe it helps improve safety because you're not obstructing critical information. So this is something that we built into the engine as well. And then the general feeling when you work with AR is that it's pretty easy to get started and kind of difficult to tune and debug and get right because you're dealing with a lot of subjective visualizations. So we've kind of built in a number of debugging tools specifically targeted for AR and how you combine computation and graphics and what are the challenges that you might face in building augmented reality applications, specifically for vehicles, right? So those are the 4 challenges that we're trying to solve with the AR SDK and the low-code tools that we offer along with it. And in terms of how all of this fits into the vehicle stack so that you get a perspective of where we fit, typically what we have is we get input signals from the ADAS system that's already in the car, the navigation app, and some basic input signals from the vehicle like vehicle speed or inertial data if it's available. And camera feed. If you want to have video augmented reality, it's a must. For AR HUDs, it's of course highly required. Sometimes working with certain ADAS suppliers, they don't allow camera feed outside of the system. That makes it a little tricky, for which we offer like reduced versions of it. And our product, effectively the augmented reality engine, that's responsible for positioning the content at the right place, compensating for latency, stabilizing content, and enabling some mixed reality scene generation, and of course correcting for the parallax of the output screen and so on. That effectively sits on top of different HMI framework, graphics engines, a spatial audio system if you have one, so that you can get 3D audio for extra immersion. So we would just feed into that, be an input source for that. And of course, if you're using if you're using some type of neural networks, they would be accelerated in a compute accelerator. And we've tried to be as agnostic as possible for the different HMI frameworks that you might already be using, different operating systems that you might be using. Typically, it goes between QNX and Android, depending on the level of safety that's required. And the general idea is that the tools we offer, we try to do one thing and one thing well. So we try to provide tools for creating the AR-specific features, that would then tie into other tools that you might already be using for HMI development. And typically, you would have like one app for each display, and you can develop those apps to run on using our AR engine and on any graphics rendering service, any spatial audio service, and so on. So that's effectively how our products would go into the cars. And I would like to close with some closing statements. So if implemented correctly, we've sort of proven to an extent and continue to prove that augmented reality can improve safety, comfort, and trust in the vehicle. We also believe that augmented reality increases the perceived value of the car, and it sort of creates a digital emotional connection with the car, because you can really communicate very expressively to the driver in front of you. And we strongly believe that this sort of enables new experiences in the car which would not be possible otherwise. We have a number of ideas on how the stuff that I showed you is more traditional stuff. We have a number of ideas on how we can bring this to, we can add different types of features and improve the experience. So if you want to discuss any ideas, feel free to drop by our booth. And yeah, that's my talk for today. Do we have any questions? Yes.
Hello, thank you for your very interesting presentation. Could you elaborate a bit more where you see the pros and cons on augmented reality in display and in the head-up display?
Sure. So augmented reality in the head-up display probably solves the problem of safety a little bit better, because you don't have to look down. You can continue looking on the road. But that's also more challenging because if implemented incorrectly, that could end up being a distraction rather than something that saves people to an extent. So it's more challenging in that sense. In the long term, we do see more people going towards augmented reality HUDs as long as the technical challenges and the price-related challenges keep coming down. We have a number of different technologies competing for the augmented reality HUD space. You have the holographic displays, which have their own set of pros and cons. You have the laser-based displays, which provide very rich contrast but are larger to integrate. So for the time being, we still see more AR features appearing on the center screen and the instrument cluster. That seems to be an easy way to get to the market because it doesn't need new hardware. But in the long term, we do see other displays, transparent displays, and also different types of visualizations for different types of modalities coming up. In terms of the actual visualizations itself, you're optimizing for different things. For augmented reality HUDs, you're optimizing for communicating information in the least distracting manner possible. So the visualizations would be different. And in the HMI, you're often optimizing for communicating information in the fastest way possible, because you want to look at the screen once and then look back to the road, right? So you don't want to interpret a lot of things. So it's different types of visualizations, but the engine itself that positions content is the same. Sure. Do we have any more questions? Yes.
Did you maybe conduct any driver distraction studies with the display-based AR systems?
We have conducted certain small-scale studies, and it really so One thing we did find is that having augmented reality on displays on all the time is considered distracting. So what we try to do is we do it based on situations. So for example, if you're driving slower than a certain speed, or if you're about to approach a turn, those are situations where we use, but it's not all the time. Do we have any more questions? Okay, I guess then we're done. Thank you, everyone.